Hello, welcome to chapter 13. This chapter is all about trigonometry. It might not make a lot of sense to you right now, but by the end of the hour you'll have a lot better idea of what trigonometry is. Now the first thing we have to look at is the definition of hypotenuse, opposite, and adjacent. If we have a right triangle, like this right triangle here, if we have angle A, the side opposite is the side directly across from that angle. Hypotenuse is always across from our 90-degree angle, and it's always the longest side. And the side adjacent is the side that's touching angle A, but it's not the hypotenuse. So adjacent, hypotenuse, and opposite. So in this situation, what side is adjacent to angle G? Well, here's angle G. The sides, both of these are touching angle G. This is the hypotenuse. So this side over here is the adjacent side, so GH. Which side is opposite of angle G? Opposite of angle G will be HK. Which side is the hypotenuse? In this, across from H, this would be the hypotenuse. Now in this situation, I want you to pause the video and think about which side is the hypotenuse and which sides are opposite and adjacent from angle G. All right, now hypotenuse is going to be this one over here because it's opposite of the 90 degrees. Opposite of G would be HK. Adjacent of G would be this third side, GH. Now, if I changed my perspective and instead of looking at G, if I wanted to look at K, now let's do it again. Let's do opposite, adjacent, and hypotenuse from K. Now, if K is my angle that I'm concerned with, opposite will now be this side, adjacent will be this side, and the hypotenuse will remain the same. All right. Now, we're coming up to a word tangent. Tangent is the ratio between the length of the opposite side to that of the adjacent side. So if I have an angle, this angle A, if I find this length and divide this over that, that will equal the tangent of this angle A. So if we looked at this triangle, the angle A is approximately 31 degrees. So we would write the tangent of 31 degrees is equal to our opposite side, which is 3, over the adjacent side, which is 5. Now, if we expanded this, the tangent of 31, if it gets bigger, if this side, until this side was 6, this side would be 10, this would be 9 and 15. Hopefully you see that all three of these are similar triangles. And if we just know 90 and 31, they have to be similar because of the angle-angle conjecture. So this 3 over 5, which is 0.6, will be the ratio here on every triangle that has a 90 and a 31. So what's the tangent of A in this situation? So let's write out tangent of A. First, we need to find the opposite side. The opposite of A is 5. The adjacent of A is 12. So our answer in this problem is tangent of A is 5 over 12. And this is a statement. If I tell you to write it out as a trigonometric statement, this is what I'm looking for. Now there's a new ratio called sine. We leave off the EU when we're writing it out. We just write, this is called sine of A. So a sine is the ratio between the length of the opposite side and that of the hypotenuse. So for A, the opposite would be A over the hypotenuse, which would be C. Now what is the sine of angle A? Sine of angle A would be the opposite side, which is 5, over our hypotenuse, which is 13. Now we have another ratio, which is cosine. This is the ratio between the length of the adjacent side and that of the hypotenuse. So in this situation, the cosine of A would be B over the hypotenuse, which would be C. So in this situation, the cosine of A would be adjacent, which is 12, over our hypotenuse, which is 13. Now, to remember which trig ratio is which, I like to write it like this. So, ka, toa. So what this means is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is something that a lot of people use when they're trying to remember their trig ratios. Now let's do some practice identifying these trig ratios. Now, what is the sine of angle E? Pause the video and write this one down on your sheet. The sine of angle E is opposite, which is 16, over the hypotenuse, which is 20. If I reduce this, it will be 8/10 or 4 over 5. Now if we do sine of angle F, now this opposite is 12 over a hypotenuse of 20. Both of those will divide by 4, so this would be 3/5. Now what's the cosine of angle E? If this is angle E, we're looking for adjacent over hypotenuse. So the cosine of angle E will equal 12 over 20. Now I want you to try this one. What is the tangent of angle E? Pause the video and see if you can get this on your own. Hopefully you're done. Tangent of E is going to be opposite, which is 16, over adjacent, which is 12. If I reduce that, that would be 4 over 3. Do the same here. Pause this and see how well you do. Find the tangent of angle B. All right, hopefully you're done. Tangent of B is going to be opposite, which is 10, over the adjacent, which is 24. So the tangent of angle B will be 5/12. Now find tangent of angle C. Hopefully you're done. That would be opposite, which is 24, over adjacent, which is 10. Now on your calculator, you can find these ratios. And I'll bring up my TI-84. If you have a different calculator, you have to play around to figure out how it works. But on your TI, you need to make sure that if you hit mode, that everything is on this left-hand side except for degree. If you do not see degree highlighted, you have to go down and over and hit enter so it is highlighted. So if we quit out of this and just push sine of 52, that answer is 0.7880. So what that means is if I have a right triangle where this angle is 52, the ratio of this side, the opposite over the hypotenuse, will always be 0.788. This ratio will always equal 0.788. Now cosine of 78, we do the same thing. Type into your calculator cosine 78. Make sure you're getting the same numbers I am, so this would be 0.2079. Now usually we go out 4 digits when we're doing trigonometric ratios. tangent of 73. It's not rocket science here. You just push tangent 73, hit enter, and that's 3.2709. It said 08, but it was 085, so that would just move the last digit up to 9. All right. And now I want you to work on this homework. Good luck.